Hello everyone, I'm just going to go through a quick summary of some of the key concepts in Unit 1, Section 1.1, 1.2. And we're going to start with the vocabulary and symbols, but I'm going to try to put it into context with why these are important, and we need a strong foundation here for the rest of the class. So a lot of times, if we're looking at statistics, we want to draw some sort of conclusion about a population of things. The problem is that it really is not feasible. Let's say we wanted to find the average weight of all adults over the age of 40. We can't really go out and weigh every single adult over 40 years old. So what we want to do is we take a sample, and we hope that we can use that sample to draw conclusions about all the population. So in order to do that, we need to have a way to tell if we're talking about the population or if we're talking about the sample. So the population, I want you to think about population as just all the things that we're interested in. Okay, just the things, not the characteristic about the things. Okay, so in many cases, we're talking about people or things or objects that we're interested in. And in order to distinguish that we're talking about the population, the characteristics, we use Greek letters when we're talking about the population. So the population is just all the things, only the things. And then what we would typically do is say, okay, well, let's take a sample. We want that sample to represent the population. So we want to make sure that any conclusions that we try to draw using the sample will really be valid to make conclusions about the population. So what we do is we take a sample of that population. All right. So the sample is a subset of the population. And we are studying units. We're observing actual units that came from the population because we want to gain information about the population. And the way that we distinguish or know that we're talking about the sample is we use Roman letters to describe the characteristics of the sample. And then we talk about N is just how many things, what subset of things did we take from the overall population. So the sample is just some of the things. The population is all the things we're interested in. Now, we could be interested in a lot of different characteristics from a population. And when we're talking about a population, we call those characteristics we're interested in a parameter. Okay, so the way that you can remember that is that when we have population starts with P, parameter starts with P. Whenever you see parameter, we're talking about the population. And whenever we're talking about the population, we're using Greek letters. We're going to focus on just a few numerical characteristics in this class. There are many more, but we're going to start with what we call a categorical characteristic. And we call that pi. Okay, pi starts with P, and it represents the proportion or the percent of the population, the proportion or percent. Okay, that will be used when you're reading a word problem. If you see the word proportion or percent or long run proportion, we're talking about pi or P. They all start with P. When we're talking about a mean or an average of the population, that means we're talking about a quantitative variable. And mean starts with M. Mu is a Greek letter. We say it M, we write it as MU, okay? But mu is just the Greek letter for M. Okay, so Greek letters for the population. So the reason why we have two different sets of symbols is because now we would take a sample and we can observe these characteristics from this sample set of data that we have captured, that we have taken. Okay, so if I take a sample of data and I calculate the proportion or the percent of success in our sample, I call that p hat. Okay, so I'm still using the word P, but now we're using just Roman letters. Okay, and then if I take my sample statistic and it's quantitative or average or mean, that symbol we use is X bar. Every population parameter has a corresponding sample statistic. Okay, so they come in pairs. We just use different symbols so that we know whether or not we're talking about the population or the sample. The other thing you can remember is sample starts with S, so samples have statistics, okay? Populations have parameters. And I like to think of it here, and if this helps you on this page. So Greek letters go with populations, and I like to think of the Greeks standing up on the Acropolis, looking down on the population of Greece, okay? So population have parameters, they use Greek letters, okay? The Greek letter for P is pi, okay? The Greek letter for M is mu. The Greek letter for standard deviation is sigma. That's an S, okay? I'm sorry, the Greek letter for S is sigma for the standard deviation. And we'll cover this symbol later, but the correlation coefficient, rho, that's the Greek letter for R. So if we're talking about the sample, when we take a sample, instead of saying pi, we say p hat, okay? Proportion of success, all right? We call that p hat, that's categorical data. Instead of saying mu, when we're talking about a mean or an average, and we're talking about the sample, it's X bar. When we're talking about the standard deviation and we call it sigma, it's the standard deviation of the population. Okay, if we're talking about the sample, the standard deviation of the sample, we're using the letter S. When we're talking about a correlation coefficient, we use rho, okay, that's the Greek letter for R. When we're talking about the sample, we call it R correlation coefficient. Again, each population parameter has a corresponding sample statistic. Populations use Greek letters, statistics use Roman letters. And here's why. So again, the statistic is a numerical characteristic, and we know it's known. We take a sample and we can calculate. It's known, it's observed, we can calculate it. We do this because we want to be able to make inferences or conclusions about the population. The symbol for the statistic when we have a categorical variable is p hat. Okay, so it represents a proportion. You think of PP, proportion or percent of success. And a proportion is a fraction. So whenever you're talking about p hat, it's important to put it in the context of how many successes did we have out of what the total sample size is. The parameter, all right, it wouldn't really be feasible to go and find, talk to every single person in the parameter and see how many successes we had out of the entire population. So it's generally unknown. So instead of being able to readily calculate it for the population, we take a sample because we can deal with that finite number of items instead of the population. When we're talking about X bar, we're talking about quantitative data. You're going to see the word mean or average. And the way we calculate X bar is whatever we're interested in, we sum them all up and we divide by how many things. So this is just, if you want to find your average test grade, you would add up all the test grades and divide by how many tests there are. And that is all we're doing here when we're coming up with the X bar. We can take a sample, we know the sample size, we can add up all the things, we can come up with that average. From a parameter perspective, it really wouldn't be feasible if we wanted to find out the average test grade for all students in the country. We'd have to add up all the students in the country, and then we'd divide through by all the students, and then that just wouldn't be feasible. Even if we could do it, it would take a long time. So it's generally unknown. What we generally would do would take a sample of all those things, and we would calculate the average or the mean. Okay, last one on this chart in this video is here's my key for deconstructing word problems. So what I want you to do first is look in the problem to see, does it say average or mean? A lot of times it's easier to distinguish if we have quantitative data versus categorical data. So I want you to read the problem. If it says average or mean, something we're interested in, if it says yes, then I know I'm dealing with a population parameter of mu, okay, M and M, and I know that in the sample that I take, it's X bar. X bar always goes with mu. If I don't see the word average or mean, then I know it is a population parameter that is categorical. And I'm going to use pi and p hat. Pi always goes with p hat, p and p. So you can read this here, you can download this, you can use this to help you when you're doing problems. Again, the easiest way I think to remember it is that mean starts with M. If you see a mean or average, mu looks like an M, that is the Greek letter for M, and then X bar always goes with mu. Otherwise, when we're talking about a categorical data, we're talking about proportions or percentages, which is the letter P. Pi is the Greek letter P, and then P hat is the symbol we use because that's the Roman letter. When we're talking about the population, we're talking about all the things and just the things. When we take a sample, we're talking about we took a subset of some of the things that we're interested in. And each of those units or the characteristic we're observing are the observational units. And we'll talk more about this after. The variable is what are we interested in, or what if we're a researcher and we had a clipboard, what would we be writing about on our clipboard about what we observed from each of these things? We'll get into that more. Okay, and this is just a summary. When we're talking about parameter, a lot of times you'll see the word interested in or claim or theoretical value. That tells you we're talking about the population, which means we're going to be using Greek letters. And then in the statistic from the sample, we're talking about X bar goes with mu, P hat goes with pi, and S goes with sigma. A lot of times students get confused with the standard error. We'll talk more about this when we're going to create sample distributions, and standard deviation and standard error just tell us like how far the data is from the center. So when we're talking about standard error, when we create a distribution of statistics, we're talking about the standard deviation of the distribution. Okay? Standard deviation, if we collected a population, we have the standard deviation of the population versus the standard deviation of the distribution that we create.